Yeah. All right. Difference in proportions. Here we go. So this can sound confusing at first. Why would we specifically want to look at the difference in proportions? The reason is if you want to compare proportions, if you want to know whether one is greater than the other, let's say, one way we can do that is I can subtract P2 to the other side. And really what I'm trying to figure out is if P1 minus P2 is greater than 0, in which case then I'm looking at the difference in proportions. All right. So if we want to make a confidence interval for P1 minus P2, here are the conditions that you have to check. Random. You're used to this. Just make a statement that the data come from two independent random samples or from two groups in a randomized experiment. The 10% condition, you now have to check for two samples. So you need to make a statement that your first sample is less than a tenth of its population and your second sample is less than a tenth of its population. And then large counts, you now have to check for both samples as well. So you need to check that N1 times P1 and N1 times 1 minus P1 are both at least 10, and the same for N2 P2 and N2 times 1 minus P2. And we will do that. We're going to do, I think, 2 examples today.
I'm going to send out, once we make sure that it's completely finalized, we put some on the but I think it will be. I'll send out a late thing for everyone.
Well done. All right. So here we're just going to check conditions on this one. We're not going to actually create the confidence interval just yet. But to give you some context of what a problem would look like, here we go. A Harris interactive survey asked independent random samples of adults from the United States and Germany about the importance of brand names when buying clothes. Of the 2,309 U.S. adults surveyed, 26% said brand names were important, compared with 22% of the 1,058 German adults who were surveyed. Let PU equal the true proportion of U.S. adults who think brand names are important when buying clothes, and PG equal the true proportion of all German adults who think brand names are important when buying clothes. Check conditions for calculating a confidence interval for PU equals PG are met. So, and again, PU equals PG is the same statement as PU minus PG equals 0, which is what we would actually be creating the confidence interval for. So conditions, random, stated as independent, simple random samples, so SRSs. Good enough. All right, the 10% condition is the one we have to check to make sure it's okay to use the formula for the standard error or standard deviation of the statistic. So here, the way we want to do it is just multiply your each sample size by 10. So for the US sample, I would say there are more than what that would be 23,090 if I multiply the US sample by 10. US adults and 10,580 German adults. So I'm just making the statement that My population is more than 10 times my sample. Good, and then large counts, we just have to do for both. All right, so I'll do my US sample here, which is N times P, or P hat. So that's 2,309 times 0.26. That's definitely greater than 10. I'm actually going to multiply that out. 2,309 times 0.26 is 600, which is greater than 10. And then I need to multiply that by the complement, 2,309 times point. Thank you. Which is 1,708.66, which is also greater than 10. All right, and then I'll do the same for Germany. So I'll do 1,058 times their p hat value, which is 0.22. It's 232.76, which is greater than 10. And then 1,058 times the complement, which is 0.78. $825.24, which is also greater than 10. All right, and the large counts, remember, just tells us that the sampling distribution will be approximately normal, which allows us to make normal calculations and create a confidence interval. All right, so there are the conditions that we need checked. Kind of cumbersome, kind of annoying, but hey, easy points. So we would still use the same general formula for creating a confidence interval. It's just our statistic is slightly different. Now it would be P1 hat minus P2 hat. And we would still add and subtract this margin of error, which is your critical value, which is determined by how much confidence you'd like to have, times the standard deviation of the statistic. Now, this formula will be slightly different. So that formula looks like that. It is in your formula packet. Here, normally, if we wanted the standard deviation, it uses the proportion P1 and the proportion P2, which are unknown. Those are the things we're trying to capture in our confidence interval. So we replace them with P1 hat and P2 hat, our statistic, in which case we stop calling it standard deviation. Do you remember what we call it when we replace those with standard error? So we replace them with P1 hat and P2 hat, and that's called standard error. All right, so here's the actual formula for a two sample Z interval. Listen, we're not going to do this by hand. We're going to use our calculator to do this. This is really cumbersome to do by hand. There's too many places where you can make a clerical error. And we have technology that can support this, and you'll be able to use your technology on the AP exam. So there's really no reason to do this by hand. All right. So far, we've been focused on doing inference when using random sampling, in which case we have to check that 10% condition. But you can also do inference when you're doing a randomized experiment. So let's take a look at that. And all it does is it eliminates the necessity to check the 10% condition because you're not taking a sample from a population. You're instead randomizing groups to treatments. All right. Patients with lower back pain are often given non-steroidal anti-inflammatory drugs like naproxen to ease their pain. Researchers wondered if taking Valium along with the naproxen would affect pain relief. To find out, they recruited 112 patients with severe lower back pain and randomly assigned them to one of two treatments: naproxen and Valium or naproxen and placebo. After 1 week, 39 of the 57 subjects who took naproxen and Valium reported reduced lower back pain, compared with 43 of the 55 subjects in the naproxen and placebo group. And we're going to construct and interpret a 99% confidence interval for the difference in proportion of patients like these who would report reduced lower back pain after taking naproxen and Valium versus after taking naproxen and a placebo. And then based on that interval, what conclusion would you make about whether taking Valium along with naproxen affects pain relief and justify your answer? All right. So let's just focus on A. First thing we have to do is check conditions. And so I'm going to state what we're talking about. We're going to create a 99% confidence interval for P1 minus P2, where P1 is the true proportion of patients who had reduced lower back pain after taking naproxen and Valium. So P1 is the true treatment, right? And then P2 is going to be the placebo group, basically. In this case, it's not a random sample, but we did randomly assign patients to the treatment group and to the placebo group. 10% we don't have to check because they're not sampling patients without replacement. They are experimenting. So 10% is not necessary to check. Large counts, just make sure your successes and failures are both greater than 10 for both groups. And for ours, we had 39 of the 57 in one group, so 39 is greater than 10. And then the complement to that would be 18, also greater than 10. And then in the second group, 43, and the complement to that is 12, also greater than 10. So we're good to go. And so we're going to use what's called a two-sample Z interval for P1 minus P2. Here's where your calculators come in. Let me open mine. All right, we're going to go to stat tests. Remember, if we're talking about proportions, your calculator should have prop in the name. We're not doing a test right now. We're doing an interval. So what we want is a 2-prop Z int, which is option B. You got to scroll down a little bit. And in this case, the order matters. So remember what you decided was P1 and what you decided was P2. For us, P1 was the Valium treatment group and P2 was the placebo group. So X1 is going to be 39 and N1 is going to be 57. So 39 out of 57 in our treatment group reported reduced back pain. And then X2 is 43. And N2 is 55, so 43 out of 55 reported reduced back pain. In the placebo group, confidence level, we want 99%, so 0.99. And that's it. We'll go ahead and calculate. We get negative 0.3114 to positive 0.116. There you go. They did the calculations by hand. Again, unnecessary when we have the function in our calculator to do that. You get the same thing. So now we want to conclude. We are 99% confident that the interval from negative 0.312 to 0.116 captures P1 minus P2, the difference in true proportions of patients like these who would report reduced pain after taking naproxen and Valium versus after taking naproxen and a placebo for a week. All right, so looking at that interval, can we conclude that the Valium helps? Why not, Sam? Okay, we're getting there. So specifically, this interval contains 0, right? And remember what a confidence interval is. It's basically an interval of plausible values of the parameter of interest. Meaning, it's plausible that there is no difference between the placebo group and the treatment group, right? Between Valium and placebo. So if it's plausible that there is no difference, then no, we can't conclude that Valium is helping, right? What would the interval need to be for us to be able to conclude that Valium was helping? What characteristic would that interval have to have? You were getting at it, Sam. What's that? Yeah, it would have to be all positive values, right? It would have to not contain 0, be all positive values, in which case we're saying that the difference P1 minus P2 is greater than 0, or P1 is greater than P2, meaning that the Valium group would be more effective than the placebo group, right? But that's not the case here. 0 is a plausible value. So that helps us answer part B. Based on our confidence interval, what conclusion would you make about whether taking Valium along with naproxen affects pain relief and justify your answer? And I would just say there is no evidence that Valium is more effective than placebo. And my justification is going to be since the interval contains 0. This reminds me of the... I'll try it with my dog. All right. This AP tip is just what I've been saying. The authors of our text even say this, that like the formula for doing this by hand is complex enough that it's easy to make a clerical error, so they say just use your calculator. Make sure when you do use your calculator that you actually name the type of interval that you are using. And that's it. We did it, folks. It's a short one.